Welcome to this session. We're going to talk about autonomous APIs. Can APIs self-heal and self-optimize? This thing I've been in my mind for a while. What if APIs could take care of themselves and all that? To be honest, this talk isn't far-fetched from the future because there are already a lot of building blocks for autonomous behaviors already exist, and we just need to connect the dots. And so in this talk, we'll be exploring what autonomy looks like for APIs and what's possible today, and how can we get to the autonomous part of APIs. Yeah, my name is Olakunle Dosunmu. I'm a backend team lead at Transact Global, and I'm a software engineer that sits at the intervention of building backend systems and infrastructure. So down to business. APIs. APIs are very fragile and they are everywhere. You know, they are very critical to how apps communicate, and there are also a lot of points of failures. And you know how it is when we have downtimes. It doesn't just affect the backend, it affects everyone, the users, the user experience, money, the cost of issues and all of that going on. And whenever issues happen, we as developers, we are always playing catch up. Catch up in the sense that we are checking logs, we are restarting servers, and we are fixing patches basically to see how we can quickly meet up and all of that. What if this cycle that we've been going through all of that cycle isn't manual? What if it can be autonomous? What if you just chill as a software engineer and you're just chilling there and AI or whatever system just does everything for you? And that's what my talk will be exploring. So what does autonomous really mean? Autonomous, when I say autonomous APIs, what I mean is that APIs that are self-aware of their own states and environment, and that can act without needing a developer to intervene. So this is the loop we are going to be exploring today. Self-monitor, self-heal, and self-optimize. So for self-monitor, you want an API that will be able to observe, keep an eye on itself, its own health and all of that, which is basically self-monitor. We want to also want an API that's able to recover from failures, which is also the self-healing process, and an API that can learn and perform and tune performance over time based on whatever issues it foresees for the future, which is self-optimization. So that whole process, when that whole process is done, we then return to what? The self-monitor process again, and then we just keep going in a loop, and we are in that loop forever, and we never break out of that for loop. So let's explore each one of these steps, each one of this process in depthly, and yeah. So what does self-monitor really mean? Autonomy starts from visibility, what you can see. The API needs to know how it is currently performing. It captures metrics like latency, error rate, throughput. You know, whenever we have issues, whenever there are downtimes on your current apps, the first thing you go through is you go and check your logs to see what the issue is. You need to see what is happening, right? And that is where self-monitor comes in. And whenever those things happen, there's always like an alert, either through email or there's a Slack alert, right? Yeah, so instead of, now we have, what we're trying to do here is have API that does all that monitoring for us. Those APIs already exist, right? What if we can now take those APIs, self-monitor APIs, and plug it as a feed into something else that then reacts? That is possible, right? The building block kind of already exists. You do not need, and at this point, you don't need human intervention to be looking at those logs and all those things happening. So, and also think of self-monitor in the case of, it doesn't always have to be like there's something that is wrong. So what if we had like a cron job that used to take like 2 minutes, like whenever it runs. It takes just about 2 minutes to run. But after, say, a deployment happened, it started taking like 5 minutes. This self-monitor process would kind of already noted that, okay, you know what, there was a shift in time taken for this cron job to run from 2 to 5 minutes, and it can start looking at, okay, what changed in that whole process and all of that. So that's basically what the self-monitor stage means. Now to the self-healing stage. Self-healing is basically correcting an issue without human intervention. So can we retry request? Can we auto-scale our servers up and down based on traffic? Can we also reroute traffic whenever a data center is down? So, and all of this. So also you can also think of when like a downstream service fails, the API can open like a circuit breaker and serve, say, cache data. Circuit breaker simply means that when you notice that a service is already down, you stop routing traffic to it and probably route it somewhere else. Maybe open, like, say, another instance of it, or say reroute it to like a cache, pick up that data from a cache, and then can it also auto-scale and do rollbacks and all of that. This stage gives us resilience, and APIs will be able to bounce back on its own without needing any form of manual restart or patching on all of that. And then to the last stage, self-optimization. Self-optimization is basically about performance. How can we improve the speed and efficiency of our APIs? We track user patterns here. Which endpoints are hot? Can we pre-warn like some caches and updates, adjust rate limits and all of that? All of this process is done. A lot of tools already do this right now. Tools, so you can see that whenever you deploy and do some stuff, a few tools will suggest database indexes for you to cache, because of, you know, that those those indexes come in like common queries and stuff, and all of these small adjustments. They look like small adjustments, but over time it becomes a lot, and it helps you optimize over time. So yeah, what does a modern stack for autonomy look like? For autonomy, we have 2 stages: the observation stage and the action stage. So observation stage is basically about our APIs being self-aware, basically self-monitor and all of that. And then observation is basically done on this stage. You pick up, what's it called? You pick up this layer. We don't fix any issue. We basically just use it to know what's happening. So for example, you have tools like Prometheus in this area, in this layer. Prometheus helps you with tracking database errors, CPU usage, and all of that. It's also good for setting thresholds, like, okay, so you know what, if error rate is less, it's say greater than this percentage, make an alert, and which is what we currently do. When error rate is say greater than 5%, send an email to this alias, or send a Slack message and add everybody on the team. Another tool for doing this is OpenTelemetry. OpenTelemetry is an open source standard for logs, metrics, and all of that. Same with Datadog and or New Relic. Those are paid tools for observability, and they help you with this. So at this stage, you have information about something, yeah, and then from here, we then take that this information we have right now, so for example, error rates, and feed it to our action layer, where all of it, this is where we make changes. So this is where autonomy becomes really real. This is where an API reacts to what is being fed. So, for example, if error rates are, you are sending a request to a particular server and that server isn't responding, so you might want to bring in a circuit breaker there, stop sending requests to that server, maybe cache, serve it from a cache, serve the data from a cache and all of that. So in this layer, we have stuff like traffic switching. which is basically switching between different servers, different versions of your API. So version 1 and version 2. So you're currently serving version 2, but there's an issue, fall back to version 1, right? All of these things happen here. We have things like Kubernetes operators, which is a way of packaging, deploying, and managing stateful applications using the CRD custom resource definitions. This helps extend Kubernetes capabilities by encoding like human knowledge, like backup, auto-scaling, healing into software that runs inside of your cluster. And last but not the least, in this stage, you have AWS Lambda/GCP, which is basically an event-driven server, managed server, event-driven code without managing servers. And you basically, at this stage, so for example, something at this stage would be, say, when a user signs up, let's say, notify us when like a server is down. The error rate on this particular service is pretty high. Notify us, do this or do that, or some stuff like that. So now, to where we are headed for autonomy to become really real, this is where we are headed. We need to do a lot of things. We need to do some ML-driven tuning. ML models are like adjusting limits on the fly, in the sense that imagine an API that learns from traffic patterns and then starts adjusting based on these patterns. So think of it this way, where the API is at the observation layer. It is monitoring for API usage per client, and then say on the norm, a client hits your server say 5 times daily. And imagine you are now getting a request from that same client where the person is hitting you about 20 times in just an hour. That is really weird, right? At this stage, if you had like an autonomous API, you can basically try to limit that user already. The user has probably been hacked or something. Also think of this in this way where a client has never performed transactions during the day. He's always active at night. He probably runs a restaurant or something. And in fintech, all of these patterns are quite really important to us because you don't want to lose users' money. So imagine that same user now performing transactions during the day. You already know that there's an issue somewhere. All of this. So in this place, ML-driven tuning, we can use to predict patterns based on observations. And then we also have proactive debugging agents. So what this one really means is, why should you be waiting for an event to happen? What if your API can foresee an issue before it happens? Today, like I mentioned earlier, debugging is really reactive. We get paged whenever an issue happens, and then we start digging into telemetry data. But in the future, with enough telemetry data, a debugging agent would be able to detect, say, for example, increased number of 500s on a new deploy. So it can quickly do what? It can quickly perform a rollback to the previous version or try to fix the issue if it can fix it, right? Or it can basically even snapshot the problem for us and alert us, the developers, and say, okay, you know what, there's an issue here, or I have even fixed the issue. That's what autonomous really means in this stage. And then last but not the least, adaptive behaviors. So an API that only exists, that not only reacts to like, but also to like patterns, but also adapt to like real world usage without a deploy. So yes, I know we've all seen the news on social media around the cheating couple that at Colgate's Coldplay concerts. So that is trending news, right? What if we have a news API that kind of caches trending news automatically and serves it from cache without we sending that request to the cache itself? That makes sense, right? And to be honest, all of this, everything I've spoken about kind of already exists in its own building block, right? We just need to be able to connect the dots between those things. Caching already exists, monitoring already exists, self-healing already exists. Okay, now all you need to do is what? Connect those two things and you're good to go. Connect your logs from your GCP servers and try to find a way connect it. Okay, whenever there's an error, instead of doing anything, trigger a what's called a Lambda service that sends the error to say Kubernetes, and Kubernetes, oh, okay, you know what, I need to auto scale or I need to downscale or something like that, all of these things. So the future is really about, like I said, APIs that will act more like agents, adaptive and self-improving all on its own. So my talk right now, so if you look at it, can you answer the question, can APIs, let's answer the question, can APIs really be autonomous? What do you think? Yes, no? Maybe. Well, maybe, yes. And to be honest, I agree with you. But, which is why, this brings me back to one of my favorite quotes by Eleanor Roosevelt. She was one of the longest serving, she's the longest serving first lady in the US. She says, the future belongs to those who believe in the beauty of their dreams. Big ideas like autonomous APIs kind of seem out of reach, let's be honest. It seems out of reach to us right now. But with every fallback mechanism that you build, with every adaptive policy that you set, with every trace, every metrics that you wire, we are currently a step forward towards building a smarter system and becoming autonomous. Autonomous is no longer a dream, let's be honest with ourselves. It's no longer a dream. It is a direction, and we will get there, either you believe in it or not. Truly, we will be there. It's a matter of years. I said years, but it could be months, to be honest. And also, you do not need to boil the ocean. You do not need to try to build your whole system to be autonomous now. You can start with a building block. Start with a small self-healing route. You can also start with like an adaptive cache, something really small, and then as confidence kind of build, your system will become self-independent and become better and stronger, and then overall we will then achieve our aim of building autonomous APIs. So take a step today and start building smarter APIs. At eTransact, we do all of this in some ways. So we do not just build autonomous APIs for our backend systems. We also try to build autonomous APIs in our systems, these APIs that our users interact with on a daily. So for example, I just finished a loan disbursement application that helps agents request for loans, they get approved, and then we set a limit based on, there's an AI that reads through their bank statement, sets limits for the amount of loans we can give out to them daily, and all of this is done autonomous. All of this is autonomous. There's little to no human interaction involved in all of this process. So I hope I have been able to convince you that autonomous API is already a direction, and it's something you would need to start working towards, and it's no longer something of a far-fetched future. It's something that every one of us, every developer, every single one of us need to start thinking about now. So that brings me to the end of my talk. Thank you very much. Are there any questions? If you have anyone that has a question? I guess not. Thank you.